Okay, so we have an aircraft for which we have some data available. So, this alpha is alpha 0 lift, right. So, alpha zero lift angle of attack of the wing is minus 2.5 degrees. CL max given as 1.2, and there is a CL max what you get. So, we talk about CL of the wing, right, and this CL max you get when you have maximum elevator up deflection, right, because you are trying to move the elevator up and aircraft is pitching up, is not it. So, this CL max is corresponding to the delta E max that is given to you. So, delta E max given as minus 30 degrees, right. Everybody is getting what I am saying. So, it should not be CL max should not be calculated as CL max of the wing minus CL max or plus CL max of the tail, right. This CL max is the CL max for the airplane, and we are assuming that the most of the lift is provided by the wing, right, and delta A is only to cause a pitching moment mainly, right. Okay. So, this gives me okay, Cm due to fuselage lift curve slope of the tail and lift curve slope for the wing you can find out from here, right, that is and this eta, which is the ratio of the dynamic presses, is given at 0.9. VH is the tail volume ratio. Wing incidence angle with respect to the fuselage reference line is 0. Tail incidence angle is given as this is related to the hinge, right. Elevator effectiveness parameter given as okay. So, this data is given and what we need to find out are these. Okay. So, for this data given you have to determine these three. All right. So, let us first try to find some numbers. Okay. We know some formula which we should directly start using and we can see where we get DCM over DCL right. See if everything is available, right. We know this, we know this, we also have fuselage pitching moment expression and looks like everything else is there. So, we can find out what this derivative is. Right. And what do we get from here? This is for stick fixed condition, right. So, we can find out what is neutral point location in this stick fixed case. Let us also try to use the trim condition, okay, and find out what is CL trim. So, CMCG for the whole aircraft, and Cm naught is so angles have to be in degrees, right, because this is per degree. So, what is CL trim? We can find out from this expression. CL trim is Now, what can you find from this? CL trim is given. Now, we have found it, right, and what I am saying is most of the lift is being provided by the wing, right. So, we are not taking into account the lift produced at the tail, which is very small as compared to the lift produced at the wing, and if I use that, I can find out what alpha trim is, right. So, CL trim is right. Any question? Okay, let us try to find out the elevator control power. Cm delta E, right. We are going to use now this information to find out the forwardmost location of the CG, right. So, we have to see what is the effect of deflecting elevator on the trim condition, right. So, if you remember, Cm delta is this. So, everything you know here, so you can find out the number. Now, delta E naught, which is the trim value of the elevator, to give you alpha trim 0, right. So, trim at angle of attack which is 0, you have to deflect the elevator by delta E naught, right, and that you can find out again from the relation which is Cm Cg equal to 0. Any question? So, this is right. I am setting the alpha trim to 0, but still have this 0 angle of attack of the wing, right. So, alpha w here is now also including that alpha 0 LW, right. Remember we are talking about, so this is the fuselage reference line, and your alpha is this, right. What is alpha w? So, wing is, let us say, right. So, one angle is joining the two points, right, the chord that is making an angle with this fuselage reference line is this IW, incidence angle of the wing, and there will be another angle which will be associated with the line which is giving you the 0 lift line, right, and that can be different, a different line than the chord, right. So, you have to account for that. So, total angle of attack at the wing will be this, right. So, you have all the numbers here, so you can find out what is delta E naught. Okay. What I need to find out is the permissible most forward location of CG. So, I use this simple relation which is right. If you remember, I had drawn this plot of elevator deflection versus CL, right, and for different velocities and different CG location, right, and what I did next was plot right to get the neutral point location. So, now clearly the most forward location of the CG is somewhere here, which is going to depend upon what delta E is, right, and then we joined this and found the neutral point, right. A similar plot of delta E versus x CG can also be drawn, right. So, different velocities for different CG, you find this derivative and extend this line, so that it will cut this x axis somewhere, that will give you the neutral point location, right. Okay. So, this came from where? This came from flying different velocities for different CG locations, right, and plotting delta E trim versus CL trim, right. And we found that this relation is linear. So, we can actually write this expression in this form. So, let us try to do some algebraic manipulation, and so writing this as right. So, corresponding to this delta E max, there is going to be a CL max, isn't it, right, and that CL max is of the whole airplane. What is this quantity? X NP minus X CG, right. But now this X CG is different. What is this X CG? Corresponding to delta E max, this X CG is the most forward location of the CG, right. So, I can put a small f there to indicate that this CG location is the most forward location of the CG. So, I can find out the third problem is finding the stick free neutral point and stick free margin. So, if I find the stick free neutral point, then I can find out what is stick free margin, right. So, So, this is a relation between the DCM over DCL free and DCM over DCL fixed, right, which includes the derivatives coming from the hinge moment, right. So, we know all these numbers here, you can find out what is this quantity. So, x and p is a free stick free neutral point and the stick free margin is this minus this, right, which is which is 10% of the mean aerodynamic chord. Yeah, if you are going back to your the same question, I will answer that later. Yes, where?
It should have been a single minus sign.
Which point you are?
That delta E naught minus DCM by DCL everything. It should be delta E naught plus minus DCM
Minus plus. I am writing this expression, right.
That is if you are doing like that, but previously given.
We can talk about that, okay.
And also if CL is maximum, then if you substitute CL max, then delta E will be minimum if you put a minus sign there. If you see that boxed expression.
Delta E is maximum up. Up is what? Up is negative, right. Up deflection of elevator is negative, right. Okay. So, let us quickly discuss another problem. These problems are actually example problems available in Pamardi's book. You know Pamardi's book, right? There is one copy in the library. Okay, I will give you the name of the book after the class. So, here is this problem. One trainer aircraft is flying level, okay, and then it starts. So, this is at 5 kilometer above sea and level, then starts climbing, okay. It climbs here and this height is now it goes up to 1 kilometer extra while climbing, and then it takes a dive. Okay. From this point it takes a dive, so that at the bottom it touches this 5 kilometer height and completes a semicircle. Okay. So, right, you are getting what I am saying. There is a trainer aircraft which is flying level at 5 kilometer, and then it starts climbing, and after reaching this additional 1 kilometer it takes a dive. Okay. Right, and it comes to the bottom of this path which is semicircular, and the bottom of this path is at this 5 kilometer level, and then it completes this semicircle. So, what it is doing is taking is pulling up, right. So, first it climbed and then it took a dive, and after that, after it reaches here at the bottom, it is trying to pull up. So, this is level flight cruise at velocity which is 100 meter per second. Right. So, given some data which are like this, wing loading is 1500 Newton per meter squared. Yeah. Right. Can you read everything? This is wing loading which is 1500 Newton per meter square. Location of the wing aerodynamic center, CG location, pitching moment due to fuselage, left curve slope of the wing, left curve slope of the tail, elevator effectiveness parameter. This is the tail arm length, right, which is 8 meter. Tail volume ratio 0.6. Downwash is 0.35 into angle of attack alpha. This is CH alpha and CH delta E, right. Tail efficiency. G1 is the gearing ratio which is connecting the stick force with the gear, right. So, that gearing ratio is this 1 radian per meter, right. You are getting so you are deflecting the stick by some amount, and that is in meter, and that is going to rotate the elevator in radians, right. SE is the platform area of the elevator part, okay, behind the hinge line. C is the chord which we are measuring behind the hinge line, right, chord line of the elevator. Okay. So, clearly the radius that it is trying to pull through is 1000 meter, right, it is clear from here. Okay, so let me tell you what we are trying to determine. One, right. So, we are pulling a G maneuver which is above the level flight condition, right, that extra G that you are trying to pull. Okay. I will quickly run through the solution, you can. So, what is happening? We are pulling a maneuver, right, this pull up. So, alpha is changing at the tail, right, that we have discussed earlier, and so at the level flight condition, what is the CL? How do you find that? You have the velocity, right. So, you can find out, you have velocity, you have this wing loading given, right. So, I can find out what is CL, which is this rho is at 5000 meters, right. So, what are we doing? We are adding some lift, right, when we are trying to pull the aircraft, right. This L prime is n into W, right, and this L is W. So, I can write this as right. So, delta CL that we need, right, to pull this maneuver is related to this CL, which is at the level flight condition, and like this, right. So, extra delta CL that you need, right, to execute any maneuver which is, so this n is greater than 1. Now, this change in angle of attack that you see at the tail will also depend upon the CL that you want, right. Yeah. Let us call this this is like some density parameter. Okay, let us call this mu 1. So, mu 1 I can find out, and that is right. Let us also find out what is you have a class. So, we can stop at this point. Both these problems are solved in Hamadi's book.